Hi students, today we'll discuss an important question which may come in your CBSE exam 2025. So you understand the question and the concepts. So the question is given: a point charge plus Q is placed at the center of an uncharged hollow spherical conductor of inner radius A and outer radius B. So you can see from this diagram, in the question it is given charge plus Q is at the center and the inner spherical shell and outer spherical shell. So inner spherical shell, the radius is A, outer is your B. So the question asked magnitude and sign of charge induced on inner and outer surfaces of shell. So you know, by principle of induction, suppose there is a positive charge, so definitely the induction will be on the other surface of this spherical shell. This will be negative and this will be in the same magnitude, only the sign will be different. So this will be minus Q. And that the outer spherical shell, similar manner, this is negative, so this will come as positive. This will come as positive. So first part, your answer will be the inner shell, that is your inner side, this will be your minus Q, and the outer, this will be plus Q. So this is clear to you. Now other part is that E at a distance of R is equal to A by 2, or second part is R is equal to 2B. So if R is equal to A by 2, so we can assume an Gaussian surface of radius A by 2. So suppose this is your Gaussian surface, the radius is your A by 2. So in this case you can find out the electric field intensity by using Gauss theorem. So what Gauss theorem tells, that the flux coming out from any closed surface is equal to 1 upon epsilon naught times the charge enclosed by the surface. And the other way also to find out the flux is your surface integral of electric field intensity for that given Gaussian surface. So you already know these things. So now we'll apply this theorem to solve the first part of B. So you can understand here, the radius we have considered as A by 2. So the surface area will be equal to, that is spherical shape, so this is 4 pi r square. So this will be equal to 4 pi A by 2 whole square. So this will come as 4 pi into A square by 4. So this is coming as pi A square. Similarly, as we know, the total flux, this will be the charge enclosed. Here, what is the charge enclosed by this Gaussian surface? This is plus Q. So we can write this one, that 1 upon epsilon naught times the charge enclosed by the surface. So this will be Q upon epsilon naught. This is the first part. And second part, how to find out that this flux in other way? This flux will be equal to surface integral of your electric field intensity. So here we can write, this will come as E into 4 pi, that is surface area. So surface area is your pi A square. Already we have found out. So now equating these two, we can find Q upon epsilon naught equals to E into pi A square. So the value of E will be equal to Q upon pi A square epsilon naught. So this is your solution for the first part. And always you know, the electric field intensity for a given spherical shell is always directed away from the center, that is radially outward. So we can tell that the direction of the electric field will be radially outward. Will be radially outward. Radially outward. So this is the way we can find out the first part. Now accordingly, the second part will be equal to, we can find out this first part we can modify also, like E is equal to, here we know pi epsilon naught, so we know the value of 4 pi epsilon naught, so I can modify this one as 4 pi epsilon naught. Now 4 I have multiplied at the denominator, so numerator I will take as 4. So this will be the formula, 4q upon a square. Understood? Now we'll solve the second part. So second part you can understand here, the distance is given as 2b. So the outer is your b. So suppose 2b means, we can draw another diagram. Suppose this is your inner one, this is your outer one. So this is your b. So second part it is asked 2b. So 2b means we can consider this will be the Gaussian surface. So similar manner, for this Gaussian surface, this is your 2b. So the flux passing through this Gaussian surface of radius 2b will be equal to q, that is the charge enclosed. So charge enclosed is plus q. This is not going to vary. So we can find out this q upon epsilon naught. Similarly, the other way to find out the flux is surface integral of electric field intensity. So this will be equal to E into 4 pi r square. In this case, your r is equal to 2b square. So we can write this one is E into 4 pi into 4b square. So now equating these two, equation 1 and equation 2, what we'll get? E is E into 4 pi into 4b square equals to q upon epsilon naught. So similarly, what will be the value of E? So E will be equal to, that will be equal to 1 upon 4 pi epsilon naught. In this case, we can take, this will be your q upon, this will be 4b square. So this is the formula to find out the electric field due to the Gaussian surface having radius 2b. So the direction for this case will also be the same. So direction will be radially outward. Radially outward. So to solve this question, you need the basic concepts regarding Gauss law. So what Gauss law states? That the total flux which is coming out from an enclosed Gaussian surface is equal to the charge multiplied by 1 upon epsilon naught. So by putting this formula, we can find out the flux, and similarly other formula also we are knowing. This is your surface integral of electric field intensity. So I think you all are getting. So in the exam, this type of questions may ask, so you can solve accordingly. Thank you.